Okay, so let's begin. So welcome everyone to this Martin Audio webinar. This week we are looking at our ViewNet control software. Just quickly introduce myself. My name's Simon Purse. I am a product support engineer with Martin Audio. So I do a lot of training, write a lot of PowerPoints and training material. We also do product support, a lot of system design stuff, and just generally any technical needs you require, you can always give technical@martin-audio.com an email, and myself or my colleagues will get back to you as best we can. I also have my colleagues Robin in the UK online with me today, and my friend over on the other side of the pond, Joe, who is online as well. If you have any questions, they will be here to answer them. So ViewNet 2.2 is the most current iteration of this software. So if you haven't downloaded 2.2, then I would definitely recommend doing so. This runs a lot more smoothly, has additional features to some of the legacy versions. So what is ViewNet? Well, ViewNet is the proprietary control software for all of Martin Audio's networked products. So we can upload optimizations created in display directly into our MLA systems or our icon amplifiers and DX4 processors. We can control all of the parameters you'd expect to, so EQ, delay, system levels, muting, etc. We can manage presets for individual products or arrays. There is ganging functionality. You can store and recall system configurations, and of course monitor your system's performance remotely, be that level metering or limiters, etc. So you can also use this software to update all of your firmware. So this is the protocol that we use to keep all of our systems up to date. So firstly, we're just going to have a very quick look at the networking sort of overview. So all of our products, as standard, support dynamic or static IP ranges. By default, they are set to auto, so they're very easy to connect to using DHCP. Icon series amplifiers, DX4 processors, and CDD-Live and our SXP subwoofers also support auto addressing, which is where they effectively allow Windows to send an IP address from your laptop via the APIPA protocol, so you don't need a DHCP server. If you're looking at a larger system, especially festival sites, something where it's mission critical, I would definitely recommend, or we would definitely recommend, static IP addressing, simply because it's a lot easier to problem solve with static IP addresses. So in the case of CDD-Live and SXP and UHub devices, you can change the IP address from within ViewNet. So you would put a DHCP server on the line, connect to your products, and then manually change your IP addresses to static if you require. With all of the other products, so Merlins, Icons, DX4 processors, this can be done via the front panel. So it's a very brief introduction to network. I don't want to go too much into it. There is a good webinar on Dante with Martin Audio products, which goes a little bit deeper into the networking side of things if you require. So the first thing you want to do when we first open ViewNet and we first sort of connect to products, before we even look at building up a system, is to check that our firmware is all up to date. It's going to ensure that all of our products communicate correctly with each other. It means that you're on the latest iteration of connectivity, so that all the bugs, or as many of the bugs as we can, have been ironed out, so to speak. And it also helps us problem solve if you have any issues, because we know the state of the devices that you currently have. So to update the firmware is a very simple process. There is a built-in firmware library within ViewNet, and you can access this either from Tools, Firmware Update Wizard, or there is a firmware update dialog box in the bottom right of the screen when you open the ViewNet software. All of the firmware updates are downloaded directly into your ViewNet software. So if you're offline in the future, as long as your library is up to date, you can still go ahead and update units out in the field, because your computer has the latest updates and you don't need an internet connection. Would absolutely recommend checking the firmware of or flashing firmware of your products in the warehouse. You don't want to be doing this in the middle of a gig. It can take a while, and you need a sort of a stable connection to be able to commence this process. So when we launch this firmware updater, providing that we've downloaded the latest files, we can then click the button Proceed Firmware Update with the library. This then scans ViewNet for all of the connected devices on the Ethernet network, and all of the devices will show up here. We can then tick any device which we wish to update. So you can see here in the example we have DX4. It's on firmware version 1.49, and there is a firmware update available. If we wanted, if there was a unit here which didn't have an update, it would tell you, but of course it would still tell you what the firmware version was. You can either choose to upgrade an individual on this network, or you can update all of the upgradable items. In the drop-down menu, you will also see that there are various versions of firmware available. It automatically selects the latest, so you will automatically update any selected device, but you can also downgrade or flash the current firmware if required. When you click next, a warning message will pop up, and it will require you or ask you to use a hardwired connection between devices. This, of course, warns you, do not turn off any of the units whilst performing a firmware update. The units generally will power cycle themselves after a firmware update anyway, so it's best just to let this process run, and they will just reboot themselves. Having said that, if you do have a power interruption during a firmware update and the unit bricks itself, so to speak, there is a way around that, and we can flash it, but not through ViewNet, as ViewNet will not recognize a product when it's in boot mode. If anybody ever has an issue with that, they can just give one of the guys in the technical department a shout, and we'll be able to sort this out for you. So the upgrades vary in time depending on the device. So for MLA, it can take 10 minutes. For CDD-Live, maybe it takes a lot less. And this is why we would always recommend doing this in your warehouse, just because if it does take a lot of time and you have a lot of units, you're going to have a system which you can't use until this process is complete. When it is complete, you will get an update dialog box, and you know that the system is ready to go. Should be aware that even if ViewNet believes that the system has completed the update, the actual unit itself still might be running through a power cycle. So don't turn off any of the units until all of the systems are back online and awake. So after we've made sure that our network's running, we've got all the latest firmware, so everything can talk to each other properly, we need to start a new project. So there's several ways to start a project. You can either click on the paper icon, select new from the file drop-down menu, or Control-N, and you will get this dialog box pop up. You can give it a name and select a location on your C drive or any other drive you have connected that you wish to store your files. It's good to store it in a logical place, because we might want to come back and recall this file later. Speaking of which, if you want to recall a file, you can either click on the folder icon, you can go to File and Open, or there's a recent projects menu there, and you can select a recent project. When you have selected a recent project, the ViewNet file will load, and assuming that you have all of the same units associated with that project online, then you can go ahead and reconnect the project to ViewNet. So that means that the ViewNet software is effectively going to scan the network and resynchronize itself with the hardware in the real world. Once it's gone through this process, it will just reconnect and you should have green lights everywhere and it's straight where you left off. But how do we get to that point? Well, we need to start a new project, as we said. So we're assuming here that we've created a new project from scratch, and we're just going to go through the tools that are available in the actual ViewNet platform. So in a project toolbar, the most useful tools are kind of that aren't to do with system parameters and are more about how the system functions are across the top of the toolbar. So we have a Discover Devices button you can see there, Master Overview, Ganging, Show Mode, Mute System, and Disconnect System. So we're just going to go through each of those to get an understanding of how these systems work. So discovering devices is the primary concern, which is where we effectively connect all of the sources on the Ethernet network and we get them to talk within ViewNet and make them accessible for our project. So upon clicking devices, ViewNet scans all of the Ethernet adapters or the network adapters, that can be via USB as well, or Wi-Fi, and it will come up with a list of all of the units that it's found on the network. So Merlin controllers appearing here with just their IP addresses shown. Other products like CDD-Live, DX4 processors or Icon amplifiers will come up with their title, as you can see CDD-Live there. Running the wizard effectively synchronizes the unit with ViewNet so that we can then gain remote control. It's important to remember that ViewNet is simply a remote control piece of software. There is no DSP within ViewNet. All we're doing is remotely controlling the DSP, which is within the individual units. So no changes are effectively made in ViewNet. It's just that ViewNet makes the changes within the DSP remotely. For MLA products, it's a little bit more complicated as the Ethernet backbone only goes as far as the Merlin. The Merlin then converts this protocol to UNet, which is another form of data protocol. We need to run the wizard and make some specific configuration decisions to tell ViewNet rather, how the arrays are deployed. So if we run the wizard on a Merlin controller, it will then go ahead and tell us how many MLA nodes are effectively attached to this Merlin. So in this example, we can see that there are 10 cabinets. We need to tell ViewNet rather, sorry, I'm going to keep saying that. We need to tell ViewNet how many of these cabinets are associated with each array. If we have one array of 10, we only need to enter one array. If we have two arrays, then ViewNet is going to assume that we have two arrays of 5. This number can be edited to reflect what is happening in reality. So for example, one hang of 3 and one hang of 7. This is exactly the same for MLA Compact as well. We can also name the arrays at this point as well. We can change their names later if we require. Assuming that your Merlin is stage left, then it will more likely find or locate PA right first. So it will go right left as you label it. MLA series devices, says MLX and DSX as well, and the MSX all have LEDs located in the front of the array boxes and in the front and rear of the subwoofers, and this allows us to locate the boxes in the real world to make sure that they are viewed in the same way in ViewNet. That way we know that we're putting the correct files or the correct optimization files into the correct boxes later on. So now that we've told ViewNet what our array configuration is, we can go ahead and identify these cabinets just to make sure that they're in the right place. So we can do that one by one, and as standard you can see that the LEDs chase from the top of the array down to the bottom. But of course in this situation we've managed to patch our UNet ring the wrong way around, so The MLD, as you can see in this example, is at the top of the array, when actually in reality, the MLD is at the bottom as it's a downfill. So what we want to do is reverse the order of this array. You're clicking the reverse button, and as we can see, now our array is the correct way around. UNet is very clever in the extent that it actually measures the latency in like an almost pinged arrival time between the boxes. So it always gets the order of the nodes in the right direction or the right cascading link, but it doesn't actually know which way round is the top or the bottom. Because UNet also returns to the MLA, it also has a redundant direction. So if we cut one of the UNet sends, it would just send the traffic round the other way. And for that reason, we need to tell the system which way it is orientated. We can also turn all of the LEDs on for the entire hang. This is quite useful if you are doing several arrays or outfills, infills, etc. Just to quickly make sure that you've selected the right box. After we've done that, we can just click next, and now the array is going to sync with UNet, and all the information that is going on within those boxes is just going to tie in with UNet so that we can control it in the main window. It's only at this point that ViewNet pulls data. It's important to remember this. If we've made a bad decision, if we've got the array the wrong way around, all we have to do is just rediscover the device again, and we just go through this process very quickly, and it's not the end of the world. Each of the UNet rings from the Merlin need to be synchronized individually. So once we've done one, we obviously need to move on to the next. Of course, this only has to happen once, because if we close the file and reconnect, we will just synchronize the system rather than having to discover the devices again. Any device which has already been discovered in a ViewNet project will not be seen if we go back to device discovery. So it only discovers new independent devices on the network. So for example, if we have a large system online and I just wanted to plug in an extra CDD-Live at front of house just for a talkback, if I plug that into the network and I run discover devices, it's only going to see that one more CDD-Live unit. The rest of the system will just remain in place. MLX and DSX is very similar to MLA discovery. There's just a few more options, just simply because there are a few more ways to deploy the system. So we have front and back options for LED, because obviously if we are deploying cardioid subwoofers, we want to be able to identify the rear of that box. So we have to tell ViewNet which LED we want to light. We can also make decisions on the amount of columns if they are ground stacked. So whether we've just got two stacks like a left and right, or are we doing a broadside array. Flown subs are ID'd in exactly the same way as a flown MLA array. But of course, we can also have front or rear facing subwoofers in such a deployment. So here in this example, we have 15 MLX cabinets. They are ground stacked, and there's 5 columns of them. So when we go to the next tab, this is what we're going to have, 15 MLX in 5 columns. These can be identified in exactly the same way, and the MLXs can be dragged around just in case we've patched them incorrectly. And then ViewNet will display the boxes in the same order as reality. If we double click on any of these nodes, this will light the LED, so we can just double check and identify. If we're doing a larger MLX array or a DSX array, we can actually discover a single array of a broadside array as 2 independent arrays. And this is quite useful if we are trying to deploy a cardioid array, for example. So here we have patched them and daisy chained the forward facing 10 boxes, and then we have looped round to connect and daisy chain the rear facing. We've then told ViewNet that we do have 15 MLXs, but there are 2 arrays, one array of 10 and one array of 5. We can then just ID them again in the same order as we did before, and drag and drop across arrays if required. Again, if we have patched them correctly, then this won't be necessary, but it's good to double check and ID your systems. Because we have wired them in this way, this allows us to be able to process both of these arrays independently, and this allows us to make some quick decisions in terms of broadside cardioid stacks. So here's an example of how we've wired these. We've gone into the forward facing and then down to the one below, and then instead of going down to the cardioid box, we've gone over. So we've got the first 10 forward facing all in one array, and then we're going at the very end down to the last cardioid box there, and then looping all the way back. So it is two distinctively independent arrays where we can draw a line between the two. It's good to, if you are making an array such as this, or a more kind of classically broadside array where you have a kind of castle top, then having an idea about how you're going to wire these systems together is very useful in terms of later in the day when we come to processing these systems. MLA Mini is a little bit different, simply because the power plant and the DSP exists only in the MSX. The MLA Mini cabinets themselves are passive in that respect, although they of course have active crossovers. One MLA system is 4 MLA Mini and 1 MSX. So that is a maximum of 4 MLA Mini to every MSX. But of course, we can have a variation of MLA Mini boxes. For example, we could have 10 MLA Mini and 3 MSX. So again, we just need to define the amount of arrays and how many MSXs are present and how many MLA Mini are present per those MSXs. There are a multitude of ways to deploy MLA Mini. So this is a decision that we have to make from the drop-down menu as well. You can fly a maximum of 16 MLA Mini or a maximum of 12 MLA Mini flown with MSX flown above, sorry. Again, we can have ground stacked MLA, we can have pole mounted MLA Mini, we can also have front fills in singles or pairs. So it's important that you define what the MLA Mini is used for, because as we later come to drop in any optimizations, this is going to become more relevant. If you make a mistake, again, all you have to do is delete that array that you've discovered, and you can just rediscover it and go back through the process. Once everything on our network has been discovered, if there's something that you haven't managed to find, then you've probably got a network issue somewhere. Once you've resolved that, you can go back and discover devices, and it will just appear and you can run the wizard again. So moving on from device discovery, the next button is the master overview. In the master overview, every input and output on the system is visible. You'll be able to meter this live. This is also an additional pop-up window. So if you have a second screen, this is a very useful window to have open. If you have a device fall off the network, you can see the amp racks there, the WPS amp rack. It will go red so that you know that you have an issue. You can also double click on any of these devices and it will take you straight to a control page where you can make alterations if required. So for example, if you notice that your DD12 as a front fill is being clipped very heavily, you can just double click on that front fill and go straight into making some active decision making to resolve that. The next button along is the ganging window. Definitely recommended that this is the first thing you do after you have discovered all of your devices. Just makes working through the system a lot easier if your ganging is already in place. If you have a large broadside array, you only have to put half the delay times in if you've put your ganging in correctly, rather than having potentially 32 or 40 independent boxes which you have to enter DSP for. Some of the ganging is absolute, others is relative. This comes down to the products that you are working with. You can you can gang whole arrays, or individual parameters within products. As you can see, there is a list of different products across the top where we have device types. That is because not all of the DSP is the same across every product in the range of Martin Audio in the portfolio. So for example, a Merlin or an MLA unit is going to have a different set of DSP to a powered subwoofer, and therefore you cannot gang everything within each of those platforms because they are different. Ganging is also stored in the ViewNet file. It is not stored within the products. So the next, if you were to open a different ViewNet file, rediscover those devices, the ganging would no longer be there. If you were to restore a project which you used previously where you had set the ganging would again be in place. Oh, excuse me, I just have some tea. So the next button along is show mode. This button simply, when you're about to do something that interrupts audio, it just says, are you sure? So anything that's going to mute an input, mute an output, change the polarity on some devices, as you can see there, it's just going to ask if you are sure. So it's quite useful, obviously, during a show. The next button is mute system. This allows you to mute every input and output of the entire system, as well as unmute every input and output of the entire system. So just as best practice, at the end of the gig, you can just come along, mute the entire system. Then the next button will allow you to disconnect the entire system. You can close the project with a save, and that is the end of the day. The next day, when you're on a festival site and you want to begin the system once more, you open the project that you previously closed, reconnect the system, unmute the system, and away you go. Just some other benefits of the toolbar that is worth knowing. On the right-hand side, we have some network status icons. When everything is online, we will see all green lights. If we have some speakers online, but some controllers offline, we will begin to see orange colors appearing. When we have either or, as you can see, we'll have all orange. When everything is offline, this will go red. It's just good to have a color coordinated indicator of the health of the system. So that's a general overview of the tools within ViewNet. We're just going to have a look at some products now and how they sort of interact in terms of parameter entry and presets. So the simplest and the first product we're going to look at is CDD-Live. This is a very quick and easy display of the tools that you have available. So we have all of the CDD-Live products and the SXP products all in one window. We can zone them if we require. And this will allow us to just gang globally across the platform. We have mutes, we have gain, delay, polarity. We can identify them with LEDs just in the same way that we can with MLA. As you can see, we can gain individual aspects of each of these products, or we can gang the entirety of them in terms of the zones. Makes it a very quick system to deploy. It's worth noting as well that we have an auto input. It's probably best to keep your system on auto. This means that regardless of whether you send a Dante signal or an analog signal, your CDD will produce it. If you select specifically one or the other, if you select Dante, for example, and then the next day you want to select, you want to use it analog audio, you're going to have to go back into ViewNet and change your selection. If you leave it on auto, it will just play no matter what. There is also a snapshot recall per device. This allows you to select for full range or with a subwoofer or a wedge, for example. There is also a custom preset which you can load within ViewNet, and you can recall this from the back panel at a later date if you require. So moving on from CDD-Live and SXP subwoofers, we have Icon and DX4 processors, Icon amplifiers. So when you double click on an Icon amplifier or a processor, you will a window will be brought up. Within that window, there are several tabs, and this is the first of them. So the first tab is gains, mutes, and limiters. This allows us to adjust input levels for that device. We also have muting for inputs and outputs. When a preset is loaded or an array is loaded, for example, there will be grayed out faders. That is because the preset has already dictated the relative levels between the boxes of that preset. We also have limiter functionality in this window. We have very complicated intelligent limiters which model different aspects of our systems. So a VX limiter effectively models a passive crossover of a passive unit and allows us to limit the LF and the HF independently, even though it is a passive speaker. And we also have thermal and excursion limiting. There is an additional limiter wizard which calculates the limiter for you just on common variables which exist for most loudspeakers, including power handling, impedance, and voice call, for example. So if you have a third-party product or a legacy product that you just need a really quick limiter for, then this can be used. Of course, we would suggest always using our presets or the specifications from our downloadable spreadsheet. The next tab is routing. So here we can select what signal we want. Do we want Dante, analog, AES? There's also a fallover selection. So if that signal is interrupted, we can have a redundant signal being sent. We can select bridge mode as well. Additionally, the Icon 81 and DX4 have an additional 4 Dante inputs, which are additional to the physical I/O. There are only 4 DSPs though, which exist within the amplifiers. So although we have an additional 4 inputs, we do not have an input EQ or level. We do, however, have all 8 output DSPs, so we can still have presets and limiters, for example. This is ideal for when you need several mixes in monitor world, for example. Additionally, the extra Dante inputs obviously can be routed to the outputs, and the outputs can be, in terms of Dante world, can be selected at what pick point we want. So do we want it post-mute, mute, pre-mute? I think there is also a pre or post DSP as well. So if you just want a clean Dante signal just to run straight through the device to be routed somewhere else, that is also possible. The next tab along is the input EQ, or the DSP, input DSP EQ rather. It's a 6-band parametric EQ with a high shelf, everything you would expect for a modern processor. We can drag and drop our frequency and gain with the click of the mouse. If you hold control, you can also change the Q. We can enter this with the faders on the right and also type in information if required on the bottom right there as well. You also notice there is a show all function. This allows us to see all of the input DSP filter curves which we have put on the system. The next tab along is output EQ. So this is, of course, independent for each output. We have an 8-band variable parametric EQ. There's high pass and low pass, of course, for each of these. The high pass and low pass are bypassed by default, so you need to click on these to ensure that they are working. We also have bypasses for the entirety of the EQ or for the individual points themselves, just so that you can double check that what you're doing is making a difference in accordance with how you want it to work. There's also a day mode, which if you've ever done a festival outside, is quite a useful function trying to fight against glare. When a preset is loaded, the EQ points in the output will be hidden. This is because they are set by default of the manufacturing preset, but we still allow for the high pass to be moved up and down because, of course, maybe you want to change your crossover point. That's absolutely fine. All the channels within the preset will be ganged. So, for example, if we have our WPM line array, you can, of course, change the high pass in any one of those outputs and it will change them everywhere. Next tab along is delay. We have input and output delay. This allows us to create a delay back to the front line, for example, and then we can have our broadside or cardioid delay in the rear. There's a polarity flip for the inputs and outputs. And there is also a kind of delay matrix routing just to visually help you decipher the decisions you are making. You can also select to have the delay available in milliseconds, meters, or feet, depending on how you wish to work. The penultimate tab is the monitoring, so we can monitor the electrical properties of the system that this particular device is connected to. So we've got supply current, link voltage, and also the thermal management, how hot this particular unit is. And then we also have monitoring for each individual output, including driver current, impedance, and the protection systems. These systems exist in the memory for up to 3 days. This would allow you to, if you did a gig at the weekend and, I don't know, maybe your wedges sounded a little bit different, a few days later, you could go back and be like, oh, okay, well, maybe I was driving those systems very hard. Or conversely, maybe your subwoofers don't sound quite as good as they did yesterday. Well, you can check the input supply current, and you can be like, oh, okay, well, the generator isn't performing as well today as it was yesterday, so I'm not quite getting the punch that I was. The last tab is the power tab. This allows us to power on or off remotely all of the icon amplifiers. We have a standby or a sleep. Standby is off until you turn it on again. When a signal is detected by this this unit, it will instantaneously turn back on again. So the DSP does not turn off, just the amplifier stage. Sleep mode is a deep sleep, and it must be woken up manually by either touching, I think is the up enter button on the front panel. We can turn it on remotely from ViewNet, or we can power cycle the device. There's also external breaker protection, which we would set to the limit. We would set that to the limit of our supply current. So in the case of our touring racks, that would be 32 amps. So that's all of the controls effectively within icon amplifiers. Just have a look at the presets, how we load the presets. This is the same in both the icons and the DX4 processors. So back in the main work window, when we discovered our devices, if we right click on any amplifier, we can open the preset manager. This will present us with a view of our connected amplifiers. In this situation, we have 3 amplifiers, but in several situations, you may have many more. And it is important to identify the locations of each of these devices and drag and drop them so that their view in ViewNet reflects reality. So we don't want to accidentally put a sub preset or change the limiters in the wrong amplifier, for example. We do this by clicking on the identify button, and this will make the front screen of any of those devices flash, and then we can move them around as needed. Loading a preset is very simple. From the preset drop-down menu, as you can see on each of those amp racks, we simply select the series that we want. Once we click on that, the product dialog box opens, and we just follow a series of drop-down menus which will refine the preset to what is required. So as you can see, in XC300, the next selection is biamp or passive. Once we've selected that, we can choose our routing. So if we want it from input 1, we can also select the DSP, where we want that input 1 to be routed through A to D. And we can also select whether we want to preserve the current input EQ on DSPA in this example, or flatten it so that we are starting from fresh. We then click add, and this is going to add this biamp preset to the loader. Clicking load will then insert this preset into the amplifier. As you can see, multiple presets can be added at the same time. It's just important, if you add multiple presets at the same time, they can only be removed at the same time. You cannot remove them again individually. You can also create a user preset if you wish in ViewNet. This can also be done offline if required. So once we have our crossover or our EQ points and our level and delay limiter settings in the correct place, we can select our ganging options if required. If this is a biamp product, for example, and there is a delay or gain offset, we can save these so when they're recalled, this offset is saved. You can see when we recall the preset later on, these parameters are grayed out so that you don't change the relative delay between components of the same preset. Once you've selected these, this ganging or your EQ, limiting, voicing, etc., we just need to save this. So if we go back to the preset manager, so that was right-clicking on any of those devices. In the bottom left-hand side, you can see there is an export preset button. This opens the dialog box, and we can make various decisions. So we can name the preset. We can then select which output is relative or do you want to be included into this preset. So here you can see output D1 is the LF. We've selected that it's LF. We've given it a label and clicked add. We've then selected output D2. We've told ViewNet that it's a HF component, given it a name and clicked add, and then entered the preset name and labels and ganging requirements at the bottom. Clicking save will then store this onto our computer if we require. We can also export this onto our desktop, for example, for our own personal preset libraries. You will get a dialog box telling you that you have successfully exported this file. This is also quite useful if you are building multiple speakers into a preset. So if you have a mid-high top box and a subwoofer, for example, that you use on a regular basis, you could make a preset which incorporates all of those outputs, and you can just recall this whenever you require, in exactly the same way that you import an XC300 preset as we saw before. At the bottom of that drop-down menu where we select the preset series, there's a user preset box. We just click on that, and then we locate the file which we exported earlier. So loading optimizations. So this is something which hopefully you're all familiar with. If you're not, then I would recommend looking at our Display 2.3 webinar. This will give you a good insight into how our line arrays and our optimized systems work. But assuming you are already familiar with these systems, we will carry on. So in Display, we can optimize our MLA, wavefront precision, or O-line systems. Once we've gone through the process of optimizing a venue or optimizing an array for a venue, we just navigate to the Export tab in Display, click on the Export to ViewNet button, and the export dialog will appear. All of the arrays by default will be selected, so all of the arrays within that file can be exported in a single D2P file. We then select the location and export. Going back to our preset manager, again, we just right click on any amplifier or processor within our work window, open the preset manager. Now we can see from the drop down menu, we have selected the WP series and we have clicked add. We now have to, we now open the optimization or the D2P file preset loader. So we need to select the D2P file which we have just exported from Display. Once we have selected that file, a list of the arrays or all the optimizations which are available within that file will appear. There are also some defaults. So we have a front fill, single or double for MLA Mini, and emergency default. So we can select these and use our arrays even if our computer, for whatever reason, if Display is not functioning or maybe our PC broke before the gig, we can still carry on with the correct voicing and limiter settings, albeit with a less even SPL or tonal response across the field. Once we've selected an array, as you can see here, we have selected the WPL preset. There's just some information in the preset info, so we can double check. Yes, it is a WPL. The number of speakers which are included within this preset and the resolution. So this is one box res. WPL is a biamp box, so that is a 12-channel preset. We can then give the array a name. We can select what channel we wish to load the loudspeakers from. By default, it will select the earliest free channel in the chain, and it will cascade across these channels until the preset is complete. We can select the input channel again and the DSP. Manual selection can also be achieved if required. For example, a lot of people like to have 2 arrays in a amp rack with the left and right relative, so left and right on channels 1 and 2 going down the rack across several amplifiers, and 3 or 4 would perhaps be the right hang going down for installs especially. Therefore, if you have an amplifier go or the power to one amplifier goes, you have lost one part of the array rather than a whole array. Of course, that depends on the size of your system and how you want to deploy your system. This can be achieved by clicking on manual, and you can see that we can independently route any part or any output to any of the outputs of the amplifiers. We can do this completely freeform as we wish. Selecting normal imports the normal voicing curve for the array which we have chosen. So in this case, WPL, it imports the normal voicing curve for the input of the WPL. Clicking preserve will maintain the current input DSP EQ for that selected DSP. This is repeated for the various arrays that we require in the system. We also have snapshots in Icon and DX4. Again, in the preset loader, we just click on the snapshot button that you can see there in the racks. We have 20 memory locations. These can also be shared between the array snapshots and the amp snapshots, which we'll have a look at. This is done simply by, in this case, selecting the snapshot button, writing a snapshot name. We select what we want to include in the snapshot, so source, input gain, input EQ, delay example. For example, we select the location, so slot number 1, and clicking save. And here you can see it's now saved within that device. We can also export and import snapshots as well. It's particularly useful if you have commissioned a system. You can export all of the amplifier snapshots, keep that somewhere safe. If anything ever goes wrong in the future, you can go back and import these snapshots from your computer back into the amplifiers, and the system will be exactly how you had it when you left. We can also achieve array snapshots, and these differ slightly from amplifier snapshots simply because they potentially span more than one amplifier. So here you can see we have some O-line and a DX4. Clicking on the array snapshot on the bottom left, this opens the array snapshots dialog box. We can click on the drop-down menu to select which of the arrays we want to include. Again, give it a snapshot name and select all of the properties we want to include within that array snapshot. And we can then recall it across several amplifiers at the same time. So that is the Icon and DX4 processors. So there's a lot of information in there. I've gone through it very quickly because I'm conscious of time, and there is a lot of information in this PowerPoint. But that gives you a good overview. Of course, if you have any questions, you can please ask them at the end. Or please give us an email at technical@martin-audio.com. So moving on to the MLA series, very similar. If you click on the array once it's been discovered, you've got the input levels. Again, you have mute control. We can select our input source, and we have the LED function again for identifying. The LED is going to be chased if we click on the play button. So input selection in MLA, we have AES left and right or analog. This will also be displayed in the right hand side. As you can see, this selection, it states AES left. There's also metering for this array, excuse me, across every output. So you can see every module has 6 outputs for MLA, and this is metered live in this view, as well as the master overview. Clicking on or double clicking on this output section will bring us to the outputs, but just before we get there, we can just quickly look at each of the individual states. We have channels 1 to 6 going from low to high. MLA Compact obviously has one less HF channel, and therefore we meter a little bit less. We also have DSP and amplifier temperature controls. As you can see here, you'll notice that the arrays at the bottom of the box are displaying a very high temperature at 120 degrees centigrade. This is probably a screenshot from a bunch of modules connected in our R&D department, and therefore they're probably messing around with things just to see what warnings pop up and such. If your arrays are displaying 120 degrees, then you might want to investigate this. So again, double clicking on the output section of the array will give us the array MLA diagnostics view. In this window, we can effectively mute the entire array and then unmute each cell by cell. So if we're sending pink noise to the array, we can then cascade our way through the entire array, making sure that every cell unmutes one by one, and that we're getting signal to every single cell. We can also do this for an entire module if we require. There are noise gates as well, and the LED will follow the array which we are unmuting or that we have selected in terms of the noise gate. We can, of course, from that point also unmute the entire array. In the event that you have a faulty device for whatever reason, if you're experiencing a strange noise, for example, you can mute the entire output stage of the amplifier rather than just the input. When you return to the normal operational screen, this will display as amps off, so that you know that there is no output from this module, whether you mute the input or the zone output. The bottom left of the overview screen, when you double click on MLA, this is the first window that comes up, much like the gains and limiters in Icon. There is also another tab for zone EQ. And here you can see the input zone for each of these arrays. This is global for the whole array because, of course, we have an optimized system here, so we only want to voice it once. The controls to this extent are exactly the same as Icon. You can also import and export EQs as required. So, for example, if you have a favorite parametric voicing EQ, you can then right-click and you can import or export rather any EQ file. You can save this somewhere and you can import it at a later date. MLX is really similar. Again, the icons or the MLA, the systems are pretty much identical in terms of control. We have the same levels, same mute functionality. The difference on the MLX, that instead of double clicking on the output section to view the diagnostics tab, we can click on the show output view button, and this will reveal the output facilities. So here we have polarity invert. We can mute the output stage. Again, we can identify with the LEDs, and you can see that we have the output gain. The output gain is actually part of the preset which we have dropped in from the MLA optimization. We're going to go into this in a minute. So effectively, when we load our MLA D2P file, our optimization for that array, if we also have discovered MLXs in the same file, they're going to appear in the same location, which we will go into in a minute. and this will effectively put the correct gain staging onto our subwoofers to allow our systems to be level matched coherently. And this is relative to the reference level in which we have optimized our arrays in the D2P file. As I said, we have delay on the output stage as well. This would allow us to make cardioid decisions. And also you can see on the input stage, there is 6 milliseconds of delay on the input. And this is also brought in from the MLA D2P file. So this is relative to the, the latency in the preset. You can also reset all the outputs back to ground zero. This will of course bring up a dialog box that says, "Are you sure?" Just so you're not making any quick decisions. Right-clicking on an MLX array or box, even in the overview, will also allow you to block the system out. This is another way of creating a cardioid block, for example, where you could have independent EQ and delay for that block. MLA Mini and MSX is again very similar. They are zoned slightly differently, as you can see. The array is one zone, the subwoofers are zone 2, and you control the entirety of the system from this location. Again, you can select analog AES left or analog or AES right, sorry, or you can select one to the MSX and the second channel to the MLA Mini, depending on your configuration. Zoning is done by a slightly different technique of just clicking on the the actual outputs you require and selecting the zone to associate them with. Again, you have a pretty standard EQ set for the MSX and the MLA Mini. We've left the high pass and the low pass open in case you wanted to create a freeway system with a larger subwoofer beneath an MLX or a DSX, for example. And we're just using the MSX here as a kickbox for the kick drum. There is also show all EQ function, and in this way that we could see how a larger 3- or 4-way system would it be interacting. On the output side, exactly the same as MLA, we can run through each of the individual nodes and we can check that the whole system in its entirety is working. There's also a polarity flip on individual MSXs, just in case you are doing something cardioid or something more complicated in terms of you have a wiring mistake. So another important thing, just like Icon, when we're uploading either O-line or MLA Mini or Wavefront Precision D2P files, we also can achieve this with MLA. This is done slightly differently by opening the preset loader. So that is in Tools and then Preset Loader. This opens the dialog box for the MLA series. So this is exactly the same for the MLA Compact or MLA the double 12. And here you can see we can select a D2P file on the right hand side. We simply locate that file that we exported from display, and this will bring up the D2P files associated with it. So here you can see there's an MLA Compact outfill, and there's an MLA and an MLD preset as well that we have created. You simply drag these into the correct locations, as you can see here. This is where you can also import your PEQ file. So there is a normal one, which is standard for speech intelligibility. We have a rock preset and an orchestral preset. We can also add a custom PEQ file, which we would have exported previously. Here you can also see the MLX is present. So we've imported normal EQ curves for these as well. This is where the reference SPL level from the MLA preset will come in and load into the MLX as required. There are target presets. So here you can see B to K. A is reserved for emergency default. So that is when, again, your computer isn't working, but you still require a gig. So you have an emergency preset. But as standard, we load our new optimizations into another one of these letters from the drop-down menu. We can also click preserve array names if we do not, if we haven't already given them a name, or if we have given them a name, sorry, then of course we want to preserve them. Clicking synchronize obviously uploads this information into the hangs, and now our presets is in place. There is also a handy load in background button that you can see there highlighted. So we're going to select a different target location, so in this case preset C, and there is a load in background button. This allows us to create several optimizations either the day before the gig or even during the gig in display, allowing for new environmental conditions, or for maybe a change in the situation where the audience has become larger. We can throw further back maybe. We can load this optimization into the background and recall it instantaneously at a later date when it is required. It's quite useful that you load in background so it doesn't interrupt audio, doesn't cause any problems. It's just there to be quickly snapped into position when required. So that is a huge amount of information. I hope that has been useful in terms of good overview of the products and their parameters within ViewNet.